So hello everyone, we need here to teach you the Boyle's law. But first thing first, here's the definition of Boyle's law. Boyle's law is stating that the pressure of a given mass of an ideal gas is inversely proportional to its volume at a constant of temperature. So I have here a question. The Boyle's law question. If a gas at 25.0 degrees Celsius occupies 3.60 liters at a pressure of 1.00 atmosphere, what will be its volume at the pressure of 2.50 atmosphere? Since this question is the missing is B2, we can derive a formula. So this is a formula we'll be using, but this is not a real formula. So we can derive a new formula for the missing one. So since P1 is besides of the missing one, P1 will be your denominator. So cancel. So copy the rest. So, B2 is equal to P2 multiplied by B1 divided by P1. This will be your formula for the missing one. So, here, B2 is equals to 2.50 atmosphere multiplied by 3.60 liters, 1.00 atmosphere, divide 1.00 atmosphere. So, 2.50 multiplied by 3.60 is 9. So, cancel atmosphere. Since this is cancelled, this is your unit, L. So, L is your unit. So, 9 liters divided by 1.00 atmosphere is equal to 9 liters.
Hello everyone, did you know what Charles law is? Well, Charles law is a law stating that the volume of an ideal gas at constant pressure is directly proportional to the temperature. This is the standard formula in initial volume times initial temperature is equal to final volume times final temperature. This is the formula of Charles. V1 over T1 is equal to V2 over T2. V1 over T1 is equal to V2 over T2. Cross multiply. V2 times T1 over T1 is equal to V1 times T2 over T2. This is the V2 is equal to V1 times T2 is equal to T1. And that's the problem. 8.0 liter of gas is collected at 0 degrees Celsius. With what will be its volume upon cooling to 30.0 degrees Celsius? V2 is equal to 8.0 liter times 333 Kelvin over 303 Kelvin. V2 is equal to 2,424 liters Kelvin over 303 Kelvin. Cross multiply. Cancelled Kelvin. This is the final answer. V2 is equal to 8 liters.
Hi everyone, did you know what Gay-Lussac law is? Gay-Lussac law defines the relationship between the pressure and temperature of a gas. According to the law, when volume is held constant, the pressure of an ideal gas is directly proportional to the temperature. This is the formula of the Gay-Lussac. Initial pressure divide initial temperature multiply by final pressure divide final temperature. So we need to cross multiply the initial pressure divide final temperature cross multiplied by final pressure divided by initial temperature. So this is the end. Final pressure multiplied by final temperature divide final temperature multiply by initial temperature multiplied by initial temperature divide final temperature, and then we cross multiply the final temperature and then final temperature. So this is the final formula. Final pressure is equal to initial pressure multiplied by initial temperature divided by final temperature. So this is the problem of Gay-Lussac. A gas has a pressure at 2.0 atmospheric at 18 Celsius. What is the new pressure when the temperature is 62 Celsius? We move the given number. This is the final pressure is equal to 2.0 atmospheric multiplied by 335 Kelvin divided by 291 Kelvin. And then final pressure divided by 670 atmospheric Kelvin divided by 291 Kelvin. So we will cross out the Kelvin, and then the final answer is final pressure is equal to 130 atmospheric.
Hello everyone, did you know what combined gas law is? Well, when we put Boyle's law, Charles' law, and Gay-Lussac law together, we come up with the combined gas law, which shows that pressure is inversely proportional to volume, or higher volume equals lower pressure. Pressure is directly proportional to temperature, or higher temperature equals higher pressure. So, we have here a question for combined gas law. It says here that a gas has a volume of 800.0 milliliters at 23.0 degrees Celsius and 300.0 torricelli. What would the volume of the gas at 227.0 degrees Celsius and 600.0 torricelli of pressure? It says here that the missing one is the final volume. So let's try to derive a formula for combined gas. P1V1 over T1 is equal to P2V2 over T2. We will multiply it by the side of the missing one. P1V1 over T1 times T2. P2V2 over T2 times T2. Then cancel out T2. P1V1 T1 over T2. P2V2 over P2. Then cancel out P2. Then transpose B2 to isolate the missing one. B2 is equal to P1 B1 times P2 over T1 times P2. And here is the formula for B2. Let's try to answer the question. For us to answer the question, let's transpose the given to the formula. B2 is equal to 300.0 torricelli multiplied by 800.0 milliliters multiplied by 500 Kelvin divided by 296 Kelvin multiplied by 600.0 torricelli. Then cancel out torricelli and Kelvin. We multiplied the given first at the numerator, then we end up with 120 million of milliliters divided by the equal of
of the given on the denominator, which is 177,600. We divide each other, then we come up with the 675.68 milliliters. And this is how we solve combined gas law. Hi everyone, did you know what is Avogadro's law? Avogadro's law is a law stating that equal volumes of gases at the same temperature and pressure contain equal number of molecules. The standard formula of Avogadro's law is initial volume divided by initial gas per mole is equal to final volume divided by final gas per mole. Cross multiply it, then you will come up with initial volume multiplied by final gas per mole is equal to final volume multiplied by initial gas per mole. I have a question here for Avogadro's law. 5.00 liters of a gas is known to contain 0.965 mole if the amount of a gas is increased to 1.80 mole. What new volume will result? Let's first derive a formula for our question. For example, B2 is missing. B1 times N2 is equal to B2 times N1. The denominator will be the side of the missing one. Then B1 times N2 divided by N1 is equal to B2 times N1 divided by N1. Then cancel out N1. Then transpose B2 to be isolated. B2 is equal to B1 times N2 divided by N1. After that, transpose the given to the formula. B2 is equal to 5.00 liters times 1.80 mole divided by 0.965 mole. After that, divide. B2 is equal to 9 liters mole divided by 0.965 mole. Then cancel out mole. Then you will come up with 9.32 liters. Hi everyone, did you know what ideal gas law is? Well, ideal gas law is very simply expressed from which simpler gas law such as Boyle's, Charles, and Avogadro's law be derived. Let us state the four gas variables and constant for a better understanding. The four gas variables are pressure, volume, number of gas per mole, temperature, and the constant of ideal gas law. The constant of ideal gas law is equivalent of 0.821 liters atmosphere gas per mole and Kelvin. This is the standard formula for ideal gas law. Pressure multiplied by volume is equal to gas per mole multiplied by constant of ideal gas law multiplied by temperature. Let's start to solve a problem. At what temperature will 0.654 gas per mole of neon gas occupy 12.30 liter at 1.95 atmosphere? As you can see, the temperature is missing. We need to derive the formula. P times V is equal to N times R times T. The one who beside the missing one will be a denominator. You just cancel out the NR. And you will get the final formula for the problem. T is equal to P times V divided by N times R. You just transfer the given to the formula. T is equal to 1.95 atmosphere multiplied by 12.30 liters over 0.654 gas per mole multiplied by 0.0821 liters atmosphere gas per mole and Kelvin. You just multiply these two. 23.985 atmosphere and liters, and multiply these two. 0.654 gas per mole multiplied by 0.821 liters atmosphere mole and gas per mole and Kelvin. And you just divide these two. 23.985 atmosphere liters divided by 0.853 liter liters, atmosphere, and Kelvin. You just cancel out the atmosphere and liters. And this is the final answer. 452.454 Kelvin. Hello everyone, did you know what Dalton's is? Dalton's law is a partial pressure states that the total pressure of mixture of gases is equal to the sum of partial pressure of the component gases. This is the standard formula for Dalton's law. PT stands for total pressure, while the P1 and P2 and P3 stands for pressure gas. So let's try to solve the problem. A container contains 3 gases, N2, O2, and AR, with partial pressure of 23.3 kPa, 40.9 kPa, and 13.7 kPa, respectively. What is the total pressure inside the container? This is easy to solve. You will just transfer the given to the formula and simply add. PT is equal to 23.3 kPa plus 40.9 kPa plus 30.7 kPa, and you will get the final answer, 77.9 kPa.